Hi all, this is the fifth section of manufacturing process module 2. In this section, I am going to discuss about gas tungsten arc welding process, electroslag welding process and plasma arc welding process. So first, gas tungsten arc welding process, GTAW welding process. Gas tungsten arc welding process, it is also known as tungsten inert gas welding process, TIG welding process. In tungsten inert gas welding process, TIG welding process or gas tungsten arc welding process, GTAW process, all are same. So in this welding process, the heat required for welding is obtained from the arc maintained between a non-consumable tungsten electrode and part to be welded. So in a TIG welding process, the heat required for welding is obtained from the arc created between, electric arc created between non-consumable tungsten electrode and the part to be welded. Non-consumable tungsten electrode are using. Non-consumable tungsten electrode means which does not consume during the welding process. The electrode does not get melted when the electric arc is created between the electrode and the workpiece. See, during the TIG welding process, the heat affected zone, molten metal and the tungsten electrode are shielded from atmospheric contamination by a blanket of inert gas. So during this welding process, inert gas shielding is used to protect the heat affected zone, molten metal and tungsten electrode from the atmospheric contamination. See, commonly using inert gas are argon and helium. Argon and helium are the commonly using inert gas in TIG welding process. So hydrogen also mixed with argon and helium in order to enhance the travel speed. For enhancing the travel speed, hydrogen gas is also mixed with the argon and helium gases. See, this TIG welding process that will produce a temperature up to 3000 Fahrenheit. 3000 Fahrenheit, that's the temperature that will be producing TIG welding process. See, TIG welding process, the TIG welding torch that contribute only heat only to the workpiece. So if a filler material, that is additional material we want to add into the molten pool, it should be add as manually into the molten weld pool. See, this is the TIG welding process setup. TIG welding process consists a TIG welding torch. So TIG welding torch that will supply the heat to the workpiece. Filler material is not supplied by the TIG welding torch. So filler material that will be added to the molten weld pool separately manually from outside. And the tungsten non-consumable tungsten electrode is using, and the electric arc that is created between the non-consumable tungsten electrode and the part to be jointed. See, in TIG welding process, electrode commonly using in TIG welding process is tungsten electrode. Tungsten electrode are commonly using in a TIG welding process. Pure tungsten are commonly using. And metal oxides used for alloying tungsten are, there is some metal oxides will be using for alloying tungsten, that are thorium oxide, synchronium oxide, lanthanum oxide and cerium oxide. So these are the metal oxide which is used to alloying tungsten, pure tungsten. Thorium oxide, once more, thorium oxide, zirconium oxide, lanthanum oxide, cerium oxide. And the type of welding current used for TIG welding or GTAW process are direct current straight polarity, direct current reverse polarity, and alternating current high frequency stabilization. So these are the three types of welding current which is used in TIG welding or GTAW process. So once more, types of welding current which is used in GTAW process or TIG welding process are direct current straight polarity, direct current reverse polarity, alternating current high frequency stabilization. So what are the advantage of TIG welding process? Good for welding thin metal. Good for welding dissimilar metals together. Little smoke or fumes. No spark or spatter. No slag. Narrow heat-away. So what are the disadvantages of TIG welding process? Slower travel speed than other process. Lower filler metal deposition rate. Hand-eye coordination is required skill. Equipment cost can be higher than with other process. Brighter UV rays than other process. Next one, what is the application of a TIG welding or GTAW process? GTAW is used to weld steel, stainless steel, nickel alloy, titanium, aluminum, magnesium, copper, brass, bronze, and even gold. GTAW can be also welded dissimilar metals to one another, such as copper to brass, stainless steel to mild steel, etc. So GTAW process that can be used for welding dissimilar metals. Example is copper to brass, stainless steel to mild steel, etc. So these are about GTAW process, gas tungsten arc welding process, or tungsten inert gas welding process, TIG welding process. All are same. So what's the important point is, in GTAW process or TIG welding process, a non-consumable tungsten electrode is used for welding process. Okay. So next one is Electroslag welding process. Short form is ESW welding process. See, Electroslag welding process. Electroslag welding process are commonly used for welding thick plate in single pass, not multiple pass, single pass. Electroslag welding process, ESW welding process are commonly used for welding thick plate in single pass. The thickness of the plate will be usually 25 mm or above 25 mm, and the welded joint is formed without multi passes, without edge preparation. That's very important point. In electroslag welding, which is used for welding thick plate above 25 mm thickness, and no, without any multi-pass and without any edge preparation. See, electroslag welding process are fully automatic welding process. Initially, the workpiece or plate to be joined are positioned in vertical position. The axis of the weld will be usually vertical direction, and the flux that will be continuously feed into the area where welding will be taking place. That's a very important point. See, this is the setup for electroslag welding process. So these are the two metal pieces that has to be undergoing welding process. So this is a completely automatic welding process. This is a flux hopper, and this is a electrode wire is continuously feeding the welding area. So the welding is happening in vertical direction in single pass. The axis of weld is vertical direction. So during welding process, the flux will be continuously supplying into the welding area. That flux got melted and a molten slag is formed. And that molten slag actually the main heat source for welding. That will melt the edges of the workpiece in electroslag welding process. Molten slag, temperature of the molten slag. See, the molten slag having a inside temperature of 1930 degrees Celsius and surface temperature of 1630 50 degrees Celsius, 1650 degrees Celsius. So this molten slag is the main source for heat in the case of electroslag welding process. Okay, so during the working of electroslag welding process, so initially an electrode wire that will be touching with the workpiece. In between the electrode wire and the workpiece, a steel wool will be using. A conducting steel wool will be using. When the electric current is passing between the steel wool, an electric arc is produced between the electrode and the workpiece. At the same time, from flux upper, flux will be flowing into the welding area. Due to the temperature of electric arc, the flux undergo melting and a molten slag will be produced. And this molten slag, once the molten slag is produced, the arc distinguishes and the electric current that is passing through the conductive molten slag. And the temperature is produced, heat will be produced due to the resistance offered by the conductive molten slag for passing electric current or flow of electric current. Once more, during the welding process, initially a steel wool will be placing in between the electrode and the workpiece to be jointed, and electric current is passing and the electric arc will be created here. At the same time, from flux upper, the flux will be flowing to the welding area. So due to high temperature of electric arc, the flux converted into molten slag. Once the molten slag touches the electrode and the workpiece, the arc distinguishes, then the electric current is passing through the molten slag. And the heat is produced by the resistance offered by the molten slag for flowing electric current. And the molten slag that melt the edges of the workpiece and welding will take place. See, molten slag, temperature of the molten slag is the main source of heat in the case of electroslag welding process. That's the main principle of the electroslag welding process. The welding is taken place in vertical direction. So there will be other two side of the plate. There is a copper shoe, water cooled copper shoe is placed. These are water cooled copper shoe, which is used to increase the solidification rate of the welded joint. So this copper shoe will be moving in upper direction as per the welded joint will be moving in upper direction for increasing the cooling rate. So this is the working principle of a electroslag welding process. So main point is electroslag welding process are commonly used to weld thick plate above 25 mm in single pass without edge preparation. That's the main point regarding electroslag welding process. Okay. So what are the advantages of electroslag welding process? Less edge preparation. Thicker steel plate can be welded in single pass. High deposition rate. No spatter. Residual stress and distortions are low. So what are the disadvantages? This process can be used only for welding very heavy plates. Application. Forging and casting of heavy thickness can be welded. High strength structure steel can be welded. Alloys like low carbon and medium carbon steel can be welded. So these are the advantages, disadvantages and application of electroslag welding process. So next one is, third one is plasma arc welding process. The short form is PAW process, plasma arc welding process. Okay. See, in a plasma arc welding process, plasma producing gas like argon, nitrogen, helium and hydrogen is ionized by the heat of an electric arc and pass through a small welding torch orifice. That's the first process. In plasma arc welding process, plasma producing gases like argon, nitrogen, helium and hydrogen is ionized by the heat of an electric arc and pass through a small welding torch, a shielding gas that protect the plasma from atmospheric contamination. So plasma arc welding process, the same principle is used for plasma cutting process also. In this process, a non-consumable tungsten electrode is used. See, additional metal if required to add. The filler rods are commonly used to add the additional metal into the molten weld pool. The work temperature obtained in this process to 20,000 degrees Celsius to 30,000 degrees Celsius. See, this plasma arc welding process are classified into two types. That is, first one, transferred arc process and non-transferred arc process. See, these are two classification of plasma arc welding process. Transferred plasma arc welding process. Second one is non-transferred plasma arc welding process. So first one, transferred plasma arc welding process. See, in transferred plasma arc welding process, the arc is formed between electrodes. See, this is the tungsten electrode, negative, and the workpiece positive. See, the arc is formed between the tungsten electrode and workpiece and shielding gas that protect the arc from atmospheric contamination. So this is a shielding gas and this is the plasma gas. Actually, this plasma gas that will be get ionized. Plasma gas means argon, helium, etc. That will get ionized, and due to this electric arc between the electrode and the workpiece, and that ionized plasma gas that will produce a high energy flame. Due to that high temperature flame, the metal piece to be get melted where area welding is taking place. So in transferred arc welding process, the arc is formed between the electrode negative and the workpiece positive. So arc is transferred from electrode to workpiece. Arc is transferred from electrode to workpiece. It possesses high energy density and plasma jet velocity. And these transferred arc welding process are commonly used to cut stainless steel, non-ferrous material used in high arc travel speed. And second one is non-transferred arc plasma arc welding process. In non-transferred plasma arc welding process, the arc is created between tungsten electrode and water-cooled constrained nozzle. So the arc plasma come out from the nozzle as a flame. So in the second one, the arc is created between the tungsten electrode and water-cooled nozzle. So this is the water-cooled nozzle. So this arc plasma that will be come out as a flame and which will heat the workpiece. See, the arc is independent of the workpiece and workpiece does not form a part of electrical circuit. In second one, the arc plasma will be created between the tungsten electrode and the nozzle, and the plasma that will be come out of the arc as a flame and that will heat the material. In this case, the workpiece is not a part of the circuit, electrical circuit. So here tungsten electrode is a negative and water cooled nozzle is the positive. See, this type possesses less energy density as compared to transferred arc plasma. It is used for welding application involving ceramic or metal spring. Second one possesses less energy density because the workpiece is not form the part of the electrical circuit. It is used for welding application involving ceramic and metal spray process. So these are the two classification of plasma arc welding process: transferred arc plasma welding process and non-transferred arc plasma welding process. So what are the advantages of plasma arc welding process? Used for welding and cutting operation. Used for welding stainless steel nickel alloy. Process is faster. Stable arc produced. Excellent weld quality. So what are the disadvantages? Welding equipment is much complex and expensive. High noise. Inert gas consumption is more. Radiations are produced. So what are the applications? Used for welding titanium plates up to 8 mm. Used in tube mill applications. Used for stainless steel tubes up to 6.3 mm. Used for welding stainless steel up to 6.3 mm. See, so these are the applications. So this about the plasma arc welding process. So I'm going to wind up this section. In this section, I have discussed three types of welding process: TIG welding process, Electroslag welding process, and plasma arc welding process. Okay, thank you.